experiment to run straight off the bat today. And that is, we're doing some more mixed precision training and we're increasing our batch size. Apparently you can double your batch size if you're using mixed precision. So let me just start this off by sharing the stream. First of all, you know the rules. If you're joining, please let me know if you can hear me. How are you on this beautiful day? You know what? Twitch is telling me, twitch.tv. Here's what we're doing on Twitch. Twitch is telling me, where is it? Where's my channel? No. Create a dashboard. Twitch is saying I'm nearly at affiliate, so I need stream on 7 different days. We're at 5 out of 7. So that's what we're pumping towards. We're pumping towards 7 days of streaming. I think this is in with a 30-day window, something like that. I don't know the full details, but we're nearly at affiliate, which is exciting. So thank you if you have been following, and thank you for tuning in if you have been watching. So let me just tweet this out. Going live on Twitch, writing TensorFlow code plus code explanations, text, playing around with mixed precision training to make models train faster. Tip: if using mixed precision, try doubling your batch size. I'm going to try this live. Come and say hi. Boom. Going live on Twitch, writing TensorFlow code plus code explanations, text. Playing around with mixed precision training to make models train faster. Yes. Tip: if using mixed precision, try doubling your batch size. Going to try this live. Yes, we are. Boom. Let's tweet it out. Get out of Twitter because that's going to distract me. We are live and come back into here. I've got this little what are we doing today? First things first, compare batch size 32 and batch size 64. And going to send a message through the Discord. Move this over to here. Yo team. Going live on Twitch, writing TensorFlow code and making materials for the new TensorFlow course. Come and say hi, party. This is what it's all about. Getting the word out. Got to get out of that so I don't get distracted. Okay, and one more. Why don't we do a little YouTube story? We can do that together. There we go here. One and done. One take and done. Add to my story. Here's what we're doing. I need 2 hands for this. YouTube, what's good? Going live on Twitch. We're going to be writing some TensorFlow code to compare batch size 32 and batch size 64 using mixed precision training. Apparently, if you use mixed precision, you can double your batch size and get great results. YouTube, what's good? Going live on Twitch. We're going to be writing some TensorFlow code to compare batch size 32 and batch size 64 using mixed precision training. Apparently, if you use mixed precision, you can double your batch size and get great results. YouTube, what's good? Going live on Twitch. We're going to be writing some TensorFlow code to compare batch size 32 and batch size 64 using mixed precision training. Apparently, if you use mixed precision, you can double your batch size and get great results. YouTube, what's good? Going live on Twitch. We're going to be writing some TensorFlow code to compare batch size 32 and batch size 64 using mixed precision training. Apparently, if you use mixed precision, you can... All right, sorry you had to hear that about 3 times, but now let's turn the phone on Do Not Disturb and put it in a drawer. Goodbye. All right, let's get to where we were. So, shaking basket, what's going on, my friend? We use less memory with mixed precision so we can increase batch size. Yes, that's what. First experiment, I've actually got that ready. So, if we see here, this is, I'll just maximize this notebook so we're only looking at one thing at a time. So this is the results with batch size 32. We got an epoch time of about 220 seconds for the first one, because that's the data's loading. Then the next one's about 150 or so seconds. And so I've got all the data loaded. I set up a global variable up here. This is a very messy notebook at the moment, but we're going to clean it, of course. I've renamed this one Trying Double Batch Size. Where's my data loader? Is it really right up here? It is. No, I'll show you where it is. Where I set batch size. Batch size equals 64. Yeah, so that's all we've changed. Everything else is the same code as what we've been using. If you want to follow along, by the way, you can go to github.com/MrDBurke TensorFlow Deep Learning, and we're working on notebook number 7. So I'll just put that into the chat. Boom. And you can hear me right, shaking basket. I'm going to assume you can. Thank you for joining in once again. I really appreciate it. So let's go down here to where we were, and we're going to kick this off. So ideally, if we double the batch size, as it says you can with mixed precision training, because we're using half the memory. Now, it doesn't actually tell us here how much. I really wish I had a terminal here so I could see how much GPU memory is being used. But this is our RAM memory. It won't actually affect the RAM here. It'll affect the GPU RAM. In our case, we're using a Tesla T4, which has just under 16 gigabytes of memory. So that's what this is, memory usage here. 16 gigabytes of memory. So if we use mixed precision, which uses a combination of float 32 and float 16, we should effectively be able to double our batch size and get similar results. So it might be faster per epoch, but the thing we want to pay attention to is, does it still get similar results in terms of loss and accuracy? So you ready? Without any further ado, let's run. See what happens. The first epoch will probably take the longest because it is loading data. But otherwise, after this little experiment, we're going to, I'll get my little notepad up. Here's what we have to do. First of all, on today's stream, we're going to compare batch size 32 and batch size 64. Using mixed precision should be able to double the batch size and stay within memory constraints. We'll find out. And then we're going to make notebook 07. So continuing on where we were yesterday. Writing text explanations for different sections. All right, let's see what's going on here. Now you'll notice that the number of batches has halved significantly. Well, not significantly, it's just halved. So this is batch size 32. So 2068 divided by 32 equals 74 batches. Now, if we have here, we have, this is to do with the training data. So there is 75,000 or so training images divided by 32 equals roughly 2368. Now we've increased the batch size to 64. It equals roughly 1184. And I believe it's actually 75,750. There we go. 1,183.5, which rounds up to 1,184. Now, will this take about the same amount of time? Interesting. All right, we'll let that run. Oh, what is the rule? By the way, we've got a new rule. New rule, ML fit, 1 epoch equals 5 push-ups. This is going to run for 5 or 3 epochs. So what do we need to do? We need to do 15 push-ups. That's the rule. You won't be able to see me, but I'll just count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Woo! ML Fit, baby. You saw it here first. I'll teach you machine learning and I'll teach you how to get shredded. So we'll let that run, then come back to it, see how the batch size goes. That's, yeah, shaking basket, that's what I hope would happen, is that the epoch time decreases as well as the evaluation metrics stay the same. That's ideal, wouldn't it be? But it doesn't look like it so far. Anyway, back to here. We're up to here. We need to add some text explanations. Alex, what's going on, my friend? Good to see you back. I'm a little bit out of breath at the moment because I just did 15 clean push-ups because we have a new rule. 1 epoch equals 5 push-ups. If you can't do push-ups, you're allowed to do squats. That's what we might do next time. We'll do squats. What other channel is teaching you machine learning and how to get shredded? Tell me. All right, so we get a little bit lower training accuracy, but basically the same time per epoch. And we get a little bit lower validation accuracy. Yeah, this is what I've noticed. If you use a higher batch size, you generally get a lower evaluation metrics. 32 is just like the magic number. Oh, reconnect. Come on, mate. Don't tell me you've deleted all the variables. That's okay. Okay, now how would we explain mixed precision? The documentation on mixed precision is actually very good. So I don't want to just rewrite everything that's here. So what I'll do is I'll probably just write a couple of sentences, because if you read these 3 paragraphs, you get a pretty good overview of mixed precision training in TensorFlow. And the same thing if you just read this Wikipedia article on precision. Like if you read these barely even 2 paragraphs, you'll get a good, so this is 5 minutes, 10 minutes of reading max. You get a pretty good overview of it. So I don't want to reinvent the wheel. I've taken some snippets here that I liked the most. First, computations are done in float 16 for performance, but the variables must be kept in float 32 for numeric stability. The beautiful thing about TensorFlow's mixed precision is it does this for you automatically. You can directly query these properties of the policy. Very small toy models typically do not benefit from mixed precision. We've seen this in previous streams when we were experimenting, because overhead from the TensorFlow runtime typically dominates the execution time, making any performance improvement on the GPU negligible. So for larger models, such as fine-tuning, you know what? Shaking basket, you know where I think we'll see the biggest improvement with the increased batch size? We may see it with, because this is just a feature extraction model, so we're only training 1 layer here. We may see a significant time improvement for when we do fine-tuning. So that's why I've set this notebook up as an experiment for batch size 64. It's about to end the 2nd epoch here. And at the end of your mixed precision models, you should have a dedicated layer, such as if you're using softmax activation, it should be in float 32. Because the D-type policy is mixed float 16, the softmax activation will normally have a float 16 compute D-type and output a float 16 tensor, which may be numerically unstable, leading to poorer results. Yeah, so we don't see that much of an increase in speed per epoch here. And I would say we're actually seeing, okay, we're seeing about the same level of performance. See, this is val accuracy with, this is a loss accuracy with a batch size of 32, and this is batch size 64. Hey, I'm not sure how to pronounce your name. IAMVAZU. I'm going excellent, thank you very much. Excited to... I'm cooking dinner tonight, so I'm very excited. It's a roast pork. I'm cooking that for the family. So I've been food shopping this morning, and now I get to write some TensorFlow code and run some experiments. Where was I up to here? And then finally, this is a great little tidbit. It's one of those things where you don't quite know why exactly, but apparently, on GPUs, ensure most tensor dimensions are a multiple of 8 to maximize performance. Does anyone know why that might be? I've read this a few places in terms of like NVIDIA's deep learning guide, TensorFlow deep learning guide, etc. But it says that most tensor dimensions, I think this has to do with tensor cores on a NVIDIA GPU, is that the number 8 is like a magic number. So that's why you see a lot of the time like batch size of 32 or 64 or 128, they're all multiples of 8. And same with hidden units in like, say, a layer, a convolutional layer. You might have 32 hidden units or 64 hidden units or something like that, because it takes advantage of the tensor cores. Very efficient to compute on. Someone may have a better explanation than me. All I know is that it's a rule of thumb. All right, so we're seeing about the same time per epoch and about the same results. Not dramatically different results with a higher batch size for feature extraction. So let's just copy that down here. That's not a game changer for me. I would say they're basically the same results, give or take a few percentage points. At this stage, float batch size 32 looks to perform better. Results with batch size 32. So evaluating the model should be basically the same. Yeah, we get half the number of batches here compared to 790. Hey, Alex, you know the tweet? Jan LeCun, batch size. This is my favorite tweet for batch size. Training with large mini batches is bad for your health. More importantly, it's bad for your test error. Friends don't let friends use mini batches larger than 32. See? How funny is that? Just a little heuristic from Jan LeCun, who's a professor at New York University, chief AI scientist at Facebook, researcher in AI and ML, etc. So yeah, there's our reason for using batch size 32. If it's good enough for Jan, it's good enough for me. Yeah, and we see slightly less accurate and slightly higher loss with batch size 64. Now again, we probably could have done the random seed a lot better in here, but we're just gonna take it off face value. Let's just keep running through this and see what fine tuning puts out when we increase our batch size. And we'll come back over to here, see how we can explain this. Set up mixed precision training. So let's just start writing. We touched on mixed precision training above. However, we didn't quite explain it. Normally, tensors in TensorFlow default to float 32. Do they actually default to float 32? I think they do. So if we go TF constant, they do. 1.0, 2.0, 3.0, and then A equals that, A dot D type, TF float 32. Yeah, but, normally, default to float 32. I'll just say that, float 32 data type. Now, if we go to precision and look up this, this is single precision floating point format. Holy goodness. Or float 32. Occupying 32 bits in computer memory. There we go. Where did we go? And this is float 32 data type, and this is single precision. Explain precision like I'm 5. That's what I want to do here. Explain mixed precision training like I'm 5. Goal for this section. Goal for TK, goal for this section. Explain mixed precision training like I'm 5. Yes, yes, yes. I don't need to save the model. What I'm doing on the right here is trying batch size 64. Load in a saved model. All I'm doing is using the same model as before, but this time we've upped the batch size to 64. There we go, batch size equals batch size. We've got the results, mixed precision with batch size 32. And let's come back over to here. Where did we load the model in? Okay, we can can all of that. How's our model look? Loaded GS model. Boom. Okay, now it's going to run. We should see the number of batches or the number of steps per epoch halve. There we go, it's halved. And ideally, it'll be faster, but maybe, maybe not. And it'll get the same results. Okay, looks like it might be significantly faster. We'll come back to that. So we're going to let this run. That'll take about, who knows, 10 minutes or so. So we've got some time to write over here. So normally tensors in TensorFlow default to the float 32 data type, unless otherwise specified. This data type, float 32, is known as single precision floating point. Actually, in computer science, look at me explaining it. Float 32 is also known as single precision floating point. And I'm just regurgitating this, what's from Wikipedia. So I'm going to copy this, known as single precision floating point format. Okay. Usually occupying 32 bits in computer memory. The 32 means it usually occupies 32 bits in computer memory. Your GPU has a limited memory. Therefore, it can only handle a number of float 32 tensors at the same time. has a limited memory. Therefore, it can only handle a number of float32 tensors at the same time. This is where mixed precision training comes in. Mixed precision training involves using float16 and float32 tensors. Involves using float32 and float16 and float32 tensors to help to make better use of your GPU's memory. Can you guess what float16 means? I like always putting a challenge in there. So if we come here, I need to put resources. Oh, that's an important point about mixed precision. So, and also we need half precision. Did I copy that? Let's go to half precision floating point. Oh no, I already opened that. Half precision floating point. 16 bits. $32 bits. So half precision. And then I also need down here, I need to include, this is a note. And we need also a resource is resource precision in computer science. We're learning about computer science here today, as well as mixed precision training. So this is what I'm doing now is I'm writing the theory behind all of the experiments that we've done. So over the past few streams and over the past week or so, I've been playing around with mixed precision, just hands-on, coding it. And I think that's very important is to, well, look at this. We don't actually see that much of an improvement in epoch time here. It lied to me. Maybe we will for the next one with a higher batch size. So what's 290 seconds divided by 65 minutes? Okay, so we might see a little increase here. I'd really like to see how much GPU utilization I have. But I don't have a terminal unless I have Colab Pro. But I have to use Colab because that's what my students are going to be using. Not everyone has a GPU-powered computer. Okay. So, can you guess what float16 means? Well, if you thought float32, you thought since float32 meant single precision floating point, you might have guessed float16 means half precision floating point. And if you did, you're right. And if not, no trouble. Now you know. Okay, I also try to write these things as I would say them to someone. Half precision floating point format. Who's got bets? Let's make some bets. Are we going to get convergence faster with a batch size of 64 over here? This is the experiment that we're running. I'm going to bet yes, because why not? I bet yes that we will get convergence. If 32 took 5 batches, I reckon we might get convergence after 4 batches, depending on what the early stopping kicks in or not. Epochs, sorry, not batches. And will we see a speed up in epoch time? I'm going to go yes, because I kind of want it to happen. So we touched on mixed precision training above. This is where mixed precision training comes in. Mixed precision training involves using float 32 and float 32 tensors to make it better. Can you guess what float 16 means? Well, if you thought since float 32 meant single precision floating point, you might have guessed. And if not, no trouble, now you know. So what does this actually do now? So now that we've kind of explained float 32, yeah, here we go. Because (32 bits), float 32. In computing, half precision, sometimes called FP16, is a binary floating point computer number format that occupies, which means each number tensors here we go. Tensors in float 16 format. For tensors in float 16 format, each element occupies 16 bits in computer memory. Is that correct? In computer memory. Beautiful. Oh, so we see a slight increase in epoch time, or sorry, decrease. About 30 seconds per epoch from a batch size of 64. That's pretty significant. 30 seconds per epoch, which of that is about 10%. That's good. Are we still getting similar numbers in terms of the... Okay, so we get slightly worse performance with a higher batch size. 10% faster, but probably 0.5% worse performance. That might be an adequate trade-off. Hamzanator, what's going on, my friend? Any advice about making a portfolio website? Yes. I would go here. You can use GitHub. If you want to do like a software type blog or something like that, that's what I would really recommend. Jekyll GitHub Pages website. Here you go, building a static website with Jekyll and GitHub Pages. Or this, I think this is Google Docs, or GitHub Docs will help you with this. I think this will be great for you. If you go into there, Docs, working with GitHub Pages, setting up a GitHub Pages site with Jekyll. It'll look something like this. So if we go fast pages, oh, you can also use fast pages. Fast pages. Wow, this is great. I'm going to read this later. Oh my goodness. Okay. I'm getting distracted. I need to have a look at this later, but you can also try fast pages. for your portfolio website. Now, this is if you're using notebooks. Fast Pages is probably the best for you. But if you just want a simple website, just go to that first link. GitHub Pages with Jekyll. That'll get you up and running. You can run your entire website out of GitHub, out of a GitHub repo for free, and it'll be amazing. I'm going to also read this later. Okay, getting distracted. How are we going over here? And let's write this. For tensors in float 16 format, each element occupies 16 bits in computer memory. So, where does this leave us? When using mixed precision training, so where does this leave us? As mentioned before, when using mixed precision training, your model will automatically switch. Is that what happens? Mixed precision training involves using float 32. Let's go back and read this. Your model will automatically switch. No, your model will make use of, from the documentation, will make use of float 32 and float 16 data types to use less memory where possible, and could we say that it does faster calculations and run faster? Yeah, use less memory where possible, and in turn run faster. Okay, does this make sense? We've got a whole bunch of computations are done in float 16 performance, but variables must be kept in float. Do we need that? We're up to here. I want to separate all the crap that I've got linked down there. No worries, Hasmonator. Enjoy, my friend. So I think that's about as much as we need to set up mixed precision training. Do we need to do that? As a result, using mixed precision training can improve your performance on modern GPUs, those with a compute capability score of 7.0 plus, by up to 3x. I think that might be enough. TK. Can we describe this with a picture? And I think they want this for sure. And is the summary any good here? Summary. Okay, beautiful. Resource. For a more detailed explanation, I encourage you to read through the TensorFlow Mixed Precision Guide. I'm a big fan of mixed precision. I might have to write an article on this later. TK picture of over 7.0. C supported hardware. Is that where we want to go? C supported hardware on for more. Resource. If you'd like to learn more about precision and computer science, the degree to which, how would you describe precision in computer science in one sentence? Is a measure of detail in which the quantity is expressed. The detail to which in computer science, the precision of a numerical quantity is a measure of the detail in which the quantity is expressed. The detail to which numerical quantity is expressed by the computer. See the Wikipedia page and accompanying resources. I think that's good enough. Because then what we can do is we can get a practical sense of what's happening. See the Wikipedia page and accompanying resources. Okay, I'm going to delete all this. Mixed Precision Guide. I'd highly recommend at least checking out the summary. Okay, I think that is good enough. Does it make sense? Goal for this section, explain mixed precision like I'm 5. We touched on mixed precision training above, however, we didn't quite explain it. Normally, tensors in TensorFlow default to the float32 data type, unless otherwise specified. In computer science, float32 is also known as single precision floating point format. The 32 means it usually occupies 32 bits in computer memory. Your GPU has a limited memory, therefore it can only handle a number of float32 tensors at the same time. This is where mixed precision training comes in. Mixed precision training involves using a mix. That's where we want to use the mix word. Involves using a mix of float32, float16, and float32 tensors to make better use of your GPU's memory. Can you guess what float16 means? Well, if you thought since float32 meant single precision floating point, you might have guessed float16 means half precision floating point format. And if you did, you're right. And if not, no trouble, now you know. For tensors in float16 format, each element occupies 16 bits in computer memory. So, where does this leave us? As mentioned before, when you're using mixed precision training, your model will make the use of float32 and float16 data types to use less memory where possible and in turn run faster. As a result, using mixed precision training can improve your performance on modern GPUs those with a compute capability score of 7.0 plus by up to 3x. For a more detailed explanation, I encourage you to read through the TensorFlow Mixed Precision Guide. I'd highly recommend at least checking out the summary. Picture, note, if your GPU doesn't have a score of 7.0 plus, e.g. P100 in Colab, Mixed Precision won't work. See supported hardware in the Mixed Precision Guide for more. Resource, if you'd like to learn more about precision in computer science, the detail to which a numerical quantity is expressed by a computer, see the Wikipedia page and accompanying resources. For now, okay, enough talk. Let's see how we can turn on mixed precision training in TensorFlow. The beautiful thing is, the TensorFlow.keras.mixedprecision API has made it very easy for us to get started. First, we'll import the API and then use it to, and then use the set global policy method to set the, what could we call this? The policy? Oh, here we go. Oh, okay, so batch 64, we'll come back to that in a second. Batch 64 increases our, or decreases our epoch speed by about 30 seconds per epoch. So that's pretty cool. But how does the accuracy finish up? Oh, so not too bad, about 0.5% off. The loss is about 0.7 higher than that. Let's evaluate it, hey? We'll go, what model did we just change? Loaded GS model. So this is our results here. Previously. Results, loaded GS model, fine-tuned, batch 64 equals loaded GS model, evaluate, test data. Results, loaded GS model, fine-tuned, batch 64. Look at that variable name. Beautiful and long. Let's see. Yo, Ashik, what's going on, man? Oh, I'm glad you're enjoying the CNN section of the course. It's an absolute masterpiece. That's very warming to my heart. Thank you, my friend. I really appreciate it. You wait till we start getting onto the fine-tuning and stuff, and the stuff that we're getting onto now. To set the, where is policy? To set the D-type policy, typically referred to as a D-type, to set the D-type policy to, this will cause subsequently created layers to use mixed precision with a mix of float 16 to mixed float 16. And then TK, what does setting this policy do for us and our models? Now, mixed precision, I want to go to the docs. Don't keep disconnecting me, Colab. I'm using you. My God, man. I just want mixed precision. I don't want policy. Mixed precision. TensorFlow Keras Mixed Precision. API has made it very easy for us to get started. And then we want set global policy. Set global policy. There we go. Hey, Ashik, guess what? I think Jeremy Howard might be giving a talk at a meetup in my home city coming up soon. That'd be pretty cool. My friend organizes the meetup, and he asked me, do I have any questions I'd like to ask him? And I'm like, let me think about that. I'll definitely think of something. First, we'll import the API and then use the set global policy method to this D-type policy, mixed float 16. Set global policy to use mixed float 16. Mixed precision. Yeah, I think so. Oh, how did our model go? Okay. Yeah, so shaking basket, this is interesting if you're still there. Batch size 64 definitely resulted in probably about a 15% or 10 to 15% increase in speed per epoch. But we do sacrifice a little bit of performance compared to batch size 32. And there will probably be some things that I could tune here to get the performance back up. But I've noticed that over heaps of experiments is that maybe we should tune the learning rate as well if we're using batch of 64. If we doubled the batch size, we should have probably halved the learning rate. Is that the linear learning rate scaling rule? Does anyone remember that? Quick find, linear learning rate. Linear scaling learning rate. Oh no, I think that's if you're just using more GPUs. Linear learning rate scaling. What is linear scaling rule? Oh, increase. What is this linear scaling rule? All the linear scaling rule says is increase the learning rate by k times, where k is the number of times your batch size and increased. All right, should we try that? Let's try out the linear learning rate scaling rule, hey? So this is batch size 64, learning rate 0000, because it's fine-tuned. And we are going to go back to where we were before and recreate our model. Reinstantiate our model. This time with and LR00. This is Adam's default learning rate. Is that Adam? TF Adam? Adam 001, isn't it? Yes, it is. Okay. Let's lower the learning rate. Or sorry, increase the learning rate. We're taking bets. What's going to happen? Ashik, in this one we're dealing with 75,000 images. They're all in tensors. So we're doing a couple of experiments that only really show their good results on large data sets. because smaller data sets, GPUs are so fast now, they just burn through them. Okay, so now we're going to double the LR in Atom, O2. But now we have to reinstantiate our model. Just going to run this. Model summary. Model is reinstantiated. Learning rate is increased. What GPU are we running? Yes, this should be fine. Okay, so all we've done with this, so this is the results with mixed precision and batch size 64, LR001. Now we've just used the linear learning rate scaling rule, and we're going to increase it by 0.001. So we're going to double it. Why? Because we've doubled the batch size. That's the linear learning rate scaling rule. Double your batch size, increase your batch size by X, also increase your learning rate by X. So if we double the batch size, we double the learning rate. Let's see what happens here. This will probably be faster because the data, the first epoch will probably be faster because the data is probably already loaded. But we need to come back to here while this is running, up to here. I'll be back. I need to go to the bathroom again because I drink so much fluid. All right, so we're going to see what the results come out of here with double the learning rate. Okay, so we turn on excellent. Nice. As long as the GPU you're using has a compute capability of 7.0 plus, the cell above should run without error. Now we can check the D-type policy. Yo, programming is lit. Hi, what's going on? My name is Daniel. It is going amazing. I am very good. We are currently running an experiment on the right here with the deep learning model, testing what happens if we double our learning rate and the batch size. And on the left here, we are writing some annotations for a module that I'm creating for one of my courses, TensorFlow course. So we're updating this notebook here to be in line with the other ones. I usually write lots of code and then explain it with text, partially so I can understand it first myself and then teach it to my students. Now we can check the D-type policy, the global D-type policy, the policy which will be used by layers in our model using the mixed precision global policy method. Come back to Mixed Precision Docs. Get the link to this bad boy. Oh, Renuga. That's amazing. How are you liking the course? Did I email you this morning about deep learning computers? Good to see you here. Thank you for joining in. Global policy. Now we can check the global D-type policy, the policy which we use in our learners and our models using the mixed precision global policy method. Yes, that will do. Okay, so yeah, we see a little bit of a speed up over here because the first epoch of this model, we've already run it in this session, so that's why it's going a bit faster. Should output mixed float 16. Great. Great. Looks like since the global D-type, I don't think I need to write that in italics for the second time. Great. Since the global D-type policy is now mixed float 16, our model will automatically take advantage of float 16 variables where possible, and in turn speed up training. Callbacks ready to roll. Mixed precision training turned on. Let's set up a feature extraction model. Callbacks ready to roll. I'm going to put a tick there. You know, make things look a little colorful. Before we get into fine tuning, let's set up a feature extraction model. To do so, we'll use EfficientNet B0. TF Kera's applications. Oh, how are we going over here? Yeah, so we don't see... Okay, so it's around about the same time per epoch, but performance-wise, it's still very similar to what we were getting before. Maybe the linear learning rate scaling rule will come into effect again with fine-tuning. Oh, thank you so much. Programming is lit. I mean, Renuga. It takes a while for my brain to process. I read a username on Twitch, then I have to remember someone's actually... Do we have to use a tool? Do we get to use a tool like weights and biases in the course, or we not use? So, weights and biases, we use TensorBoard in the course. So TensorBoard.dev. So we use this, but the beautiful thing is I tried to keep the course, because TensorBoard is a part of TensorFlow, so I tried to keep the course as just using pure TensorFlow as much as possible. However, the beautiful thing is, because we use TensorBoard, you'll find that the code that we writ integrates very well with weights and biases. So if you go through, once you've done the TensorFlow course and you go through weights and biases introduction, you'll find that the code that we use with TensorBoard can be integrated to weights and biases in about 2 lines of code. I love using weights and biases, but I tried to keep the course strictly focused on pure TensorFlow. And then if you want to use weights and biases, you can. It'll integrate very well with what we've done before. But I'm so stoked to hear that you're enjoying it. Thank you so much, Renuga. I'm going to be streaming almost all of the rest of the materials as much as I can as it comes out. So if you want to see previews of what's to come, right now I'm working on this, 07 Milestone Project 1. And then I'll probably do these two at the same time. So these 2 modules will come out at the same time. And then this one will come out as the last one. So then it'll be 11 notebooks in total, 11 modules. A lot of TensorFlow. We'll download this without the top layers using include top equals false parameter. Yeah, you're right, Renuga. Weights and biases is very easy. Maybe we could do a live stream in the future on using weights and biases with our TensorFlow code. That'd be fun. I'm going to put this as a note here. Oh, come back to our mixed precision. How did we go? Oh, so we see a slight degrade in the time per epoch doesn't really change. So we're running a few things at the moment here. We're running an experiment on the right, and we're editing text over here, but that's okay. I just want to come into here. So we doubled the learning rate, and we now see that the validation accuracy is slightly worse, about almost a percentage worse than what it was with batch size 32. So let's copy this down to here. Results with batch size 64 and LR. Because what is the learning rate? The learning rate is the amount by which our model tries to update its weights. So the higher, the more it tries to update its weights to reduce the loss. The lower, the less it tries to update its weights per epoch to reduce its loss. And a lot of the default learning rates, with all of the optimizers in TensorFlow and other deep learning frameworks, a lot of the default learning rates work pretty well out of the box. Of course, you can tune them, but they do work pretty well out of the box. Okay, so when we evaluated on the whole test data set, it's not too far off where we were before with LR 0.002. About half a percentage off. But again, this is a little bit of randomness, so give or take. Now, let's go back to where we were before. We're going to fine tune our model, this time with a higher learning rate. on this side. I think we've already got the model. I'm going to actually reload it. A weights and biases stream would be great. Thank you, French Toast Mafia. Oh, that's how we can monitor GPU usage. I should have done that at the start. We can use weights and biases for monitoring GPU usage. I'll keep that in mind for a future stream, okay? We will definitely get some weights and biases action happening. Note, since we're using mixed precision training, our model needs a separate output layer. For example, softmax with D-type with a hard-coded D-type equals float 32. For example, yeah, I've got, so right now my focus is finishing the TensorFlow course, of course. Hold on, let me fix this. What is going on with my mic? Okay. That should be all right. So right now, my sole focus is finishing the TensorFlow course. But after that, I will be doing a bunch more video making and live streams on a whole bunch of different stuff in machine learning. For example, with the hard-coded, this ensures the outputs of our model are returned back to the float 32 data type, and which is more numerically stable than the float 16 data type. Important for loss calculations. Now, this is actually said here, output. See the building the model section in the TensorFlow mixed precision guide for more. And of course, I'm also going to be working on quite a large project, but I'm not going to talk about that because if I talk about that, it feels like I've already done it. Okay, have we loaded our model? Yes. Okay. Now we need to check. We want to compile this with a higher learning rate now and see if a higher learning rate influences fine tuning. So before we used 002 for feature extraction, now we're using 0002. So the rule of thumb for fine tuning is you turn your learning rate 10 times lower than the default. Now, is that an exact rule? Of course not, but it seems to work well in practice. And of course, as always, you can tune these things. So do we have results here with, so this is results with batch size 64. Either way, we beat the deep food paper. Now we want results from fine tuning with prefetch data, mixed precision with batch size 64 and LR002. Let's run this. What do you think will happen? We've increased the learning rate by the same amount as we increased our batch size. So we doubled the batch size for this experiment, and now we've also doubled the learning rate. Build feature extraction model. Time to build a model capable of beating the deep food paper. What do we want to do? We want to build the feature extraction model first. So we're going to be fine-tuning an existing, no, because our data set is quite large, that's what we want. Because our data set is quite large, we're going to move towards fine-tuning an existing pre-trained model. Efficient net B0. But recall the typical order for using transfer learning is build a feature extraction model, replace the top few layers of a pre-trained model, and then fine-tune if necessary. Train for build a feature extraction model, replace the top few layers, train for a few epochs with lower layers frozen, fine-tune if necessary with multiple layers. That's not very helpful, is it? We need a picture here, don't we? That sounds good to me. What's happening over here? Oh, okay. The performance with the higher learning rate looks like it started off pretty well. All right. So this might help with fine tuning. Yeah, so this is what I was talking about before. With tweaks usually show their performance improvements, such as us increasing the batch size of the learning rate. Tweaks usually show their performance improvements better on larger models. That's what I found. We need to get out of this. Let's close all of the tabs we don't need so we're not getting distracted. And we're seeing very similar training times to what we've seen before, so nothing outlandish. But this is good. This is with 75,000 images in the training data set. Yes, you're right. It is 10 past 2 at the moment. What are the monitor sizes? So this monitor, this is 24 inches, and this one is 27 inches, though I think this one is probably a little bit big for me. I prefer probably 24 inches, but this is, it's a good monitor, so I'll just use it there. But I mainly, like, this has just got my streaming stuff on it. I mainly really only use this one monitor with 2 split windows here like this. I've got an idea. Before, Does Grammarly work here? Renuga, how do I stay up with the tech news? Twitter and various tech companies' blogs. So like Google AI blog, Facebook AI blog, all those sort of things. That's the main two, but company blogs and Twitter. And some companies do newsletters, so I use the newsletter as well. How's that doubling the batch size going? Doubling the learning rate. Okay, we're getting very similar results. Mixed precision. Yeah, so I think what I'm trying to say here is that a layer stores its variables in float 32, but computes in mixed float 16. There we go. Already automatically stores and computes variables and computes on Mixed Precision API automatically causes layers which can benefit from using float 6 mixed float 16 D-type policy to use it. It also prevents layers which shouldn't use it from using it. Is that what I'm trying to say? Nah, that's not what I'm trying to say. I'm going to put that one down below, and then they want a key. Note, a layer can have a D-type of float 32 and a D-type policy of mixed float 16. Because it stores its variables, weights, and biases in float 32, more numerically stable. However, it computes in float 16 faster. we can also check the same details for our model's base layer. Our model's base model. Now, some of these layers actually use float 32. Yeah, normalization. Index 2, no normalization. Okay, now we're up to fitting. Oh, have we been adhering to our rule? Okay, wow. Increasing the learning rate over here resulted in a better result, I believe. 81% with a validation loss which is lower than before. So let's see how it performs. Okay. This is batch size 32, learning rate 0001. Don't copy my Notion setup. Just create your own. That's the whole purpose of Notion. I've never watched a video on setting up Notion. I just tried to use it. Now let's run this. So batch size 64 and learning rate 0002 may have improved. Yeah. This is my Notion. So here's one of the projects I worked on. And then I just basically create another page for every time I want to work on a project. So over here, I've got one for the ZTM TensorFlow Deep Learning course. I've got a blog page. I've got a YouTube page. I've got one for the hands-on machine learning book. All of my favorite pages in that book. So I just make these whenever I need them. Getting TensorFlow Developer Certified. Curriculum. Yeah. So that's my Notion have a lot of example pages as well. So I think it's one of those tools where you just kind of have to set it up in a way that suits you best. Oh, wow. Okay, we get a fairly significant improvement over here, about 1%, using a higher learning rate and a lower loss. That's something to keep in mind going forward. Now, I said before, we aren't adhering to our rule. We said over here, so we've done that little experiment. We haven't done 1 epoch equals 5 push-ups. So I'm going to run this and do 15 push-ups. And also do 15 squats because we haven't been doing that. I'll use 3 epochs here. All right, 15 push-ups, 15 squats. If you're watching, you have to do this as well because that's the ML fit rule. 1 epoch equals 5 push-ups. Squats are okay. We didn't do 5 push-ups before, so we have to do squats and push-ups now. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Woohoo! Okay. 15 squats. 1, 2, 3, 4. Squeeze those glutes at the top. Ready? Thrust through. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Boom, boom. This is what's on. Okay. So we've done the text for that. Now what else do we need text for? I think that's good enough. Have I got a note here? Food vision. Did everyone do their push-ups and squats? So we're up to here. Fit the feature extraction model. We've run a few experiments. We found that a higher batch size and a learning rate results in about 10% faster training. So there's a tidbit. If you increase your batch size, increase your learning rate. Now we have to go back through here. So this is a little bit of a hacky way to load in some weights, but it works. So we're just demonstrating a point here. Models, clone model. So the clone model method clones a model, but resets all of its internal weights. Model cloning is similar to calling a new model and new inputs, except that it creates new layers and thus new weights, instead of sharing the weights of existing layers. Beautiful. See you, Ranuga. Thank you so much for tuning in. I might have missed you, but I hope you had a fun time and enjoy the TensorFlow course. I'll see you next time. Programmer D, what's going on? Or Programmer Nerd, Programmer D. How are you? Nice to meet you, my friend. We're writing some TensorFlow code right now, and also writing some text to describe what we're doing. Where are you from? I'm from Brisbane, Australia. Yep, this is my house. Well, it's an apartment actually. But no, this is where I live. I'm in my office right now. My bedroom is up those set of stairs. So if you walk up there, that's my room. This is an office, which is actually a bedroom as well, but I just use it as an office. And up there, you can see that open door, that's the bathroom. And then downstairs is the kitchen. But I'm working from home at the moment. Actually, I've been working from home for the last couple of years now. Load in and evaluate checkpoint weights. Beautiful. We've added some text there. Let's go back. Are we checking off what we're doing? Oh, you're from Sri Lanka? That's awesome. Thank you for tuning in. The live stream's going all over the world. What are my brothers doing now? Good question. I'm not sure what they're doing now. One of my brothers, Will, is probably at work. And Sam and Josh, I'm not sure. My brother also live streams on Twitch, but he live streams video games. So I think it's twitch.tv/warmtenny. Warm Tenny Twitch. No, it's actually just Tenny. Tinnie. Oh no. No, here it is. Tenny TV. This is my brother. So my brother live streams video games on Twitch. You can go and follow him there. Boom, there we go. About. Young Aussie lifeguard trying to make some sort of a career from playing games. I love playing first-person shooters, but don't mind geeking out on an MMO. Oh, you can write commands in Twitch? Huh. Hell yeah. Okay. Cloning the model preserves the D-type policy of layout but doesn't preserve weights. Boom. Using the save method. Don't bother with multivitamins. Lindy newsletter. Lindy man. Here you go. Don't bother with vitamins. Multivitamins are bogus. Multivitamin supplement stuff turned out bogus and even dangerous, e.g. vitamin A should have protected from lung cancer but probably causes it. And new data suggests the same for B12 supplements. So don't bother supplementing basically any vitamins except for maybe like magnesium or something like that. Huge industry, but zero positive effects and possibly many negatives. Program nerd, do you watch YouTube? Yes. If yes, how much time? I don't know, I never measure it. When you want to label your image data from a data frame image ID, do we got to use flow from data frame? Yes, that's one option of doing it. Flow from data frame. There you go. That's one option with image data generator. And if we go, there's another one, TensorFlow image data set from data frame. I think this is. Let's go to the TensorFlow Keras pre-processing. I think that's what you're after. Flow from data frame. Yeah, most blogs use multivitamins because it's just something easy to dump in. But here's my take on it, right? If it hasn't been around for 1,000 years, avoid. That's a very simple heuristic that you can use. Will you make a PyTorch course? If enough people want a PyTorch course and I learn enough about PyTorch, maybe. But after the TensorFlow course, I could just remake my entire TensorFlow course in using PyTorch instead. That would be an option. Loading a save model also retains all of the underlying layers. Okay, where are we up to? Fine tune all of the layers in our base model, since we have so much data. See you later, program nerd or program nerd. Have a great day. Yeah, Alex, open in Colab, you can go save a copy in GitHub. This will save this notebook to GitHub, and then include link to Collaboratory, which will give it the button, do you want to open this notebook in Colab? Is that what you mean, like in the notebook itself? So in here, this notebook will have at the top, open in Colab, is that what you mean? Otherwise you can go, how to add open in Colab button to notebook. Open in Colab badge. Here you go. You've also got this one as well. You can just add it hard-coded in if you wanted to. Now we're creating some callbacks for fine-tuning. A couple of very important callbacks for fine-tuning is early stopping, model checkpoint, and reduced learning rate on plateau. Early stopping is basically a regularizer, which means as soon as our model starts to overfit, so the val loss starts increasing too high, we want our model to stop training. And we can save our model's progress by checkpointing, saving the best model based on a certain parameter. So validation loss. So say, for example, we wanted to just fine-tune for 100 epochs. We could set our model to stop training after validation loss stops improving for 3 epochs. And along the way, we're saving a checkpoint every time the validation loss is the lowest. So with these two callbacks alone, we could just set our model training indefinitely. And then as soon as overfitting starts to creep in, we could stop training and we'd make sure that we'd have our best model saved to a checkpoint. How delayed is your video and chat, Ashik? I think the transfer learning with TensorFlow part, yes, scaling up. They would have been loaded in really recently, yeah. So recorded those videos last week, and they've been edited, and now they're part of the course. So this is the next section that's going to come after that. Since we're using the early stopping callback, it might stop before reaching 100 epochs. Running the cell below, doing so with unoptimized data pipelines and without mixed precision training, but don't worry, the code we've written above will ensure it runs as fast as possible. More like 4 to 5 minutes per epoch. You mean my voice is delayed, like the video is coming quicker than my voice, or the chat, like as in the Twitch, the text chat? Shivans, thank you so much. The streaming is primo. I thank you for that. Hi, Bioglu. Am I saying your name right? Bioglu. Nice to meet you. Dan, you talk about referring to hands-on ML. Do you refer to Python for data as analysis as much? I haven't recently, but where is it? Oh, it's up there. Because the pandas documentation is actually quite good. So every time I need to use pandas, or because that's what Python for data analysis is mainly based on, every time I use that, the documentation usually helps out. But for hands-on machine learning, I find that just keeps because a lot of the stuff in machine learning is like rules of thumb and experimental, whereas pandas is kind of, there's usually, I mean, there's a number of ways you can do things, but there's usually one best way of doing things, if that makes sense. So I did buy the hard copy of this, but I haven't really gone through it as much as I have hands-on ML. But yes, you're right. I should start referring to this more when I start doing more structured data stuff. Put that down there for the time being. Let's go back here. Oh, I could do a picture here, couldn't I? TK picture. Compare the time between optimized data pipeline and mixed precision to unoptimized data pipeline and mixed precision and no mixed precision. Bahadir, nice to see you, my friend. Oh, you've learned a lot from my courses. Thank you so much. I really appreciate it. It's good to see you here. Thank you for tuning in. Yeah, Turkish food is one of my favorites. Haha, Siobhan's best and worst experience as an Uber driver. Huh. I've got an idea. I can show you a photo of one of my best experiences. Oh. I'm going to put this over here because this is my Photos app, so you can see everything. I mean, I'm a public figure, but I've got a lot of photos in here that are maybe not suited for Twitch. When I was driving Uber, one time I was with this family, and do I have it saved to my favorites? If not, I'll just tell the story. Because I can't be bothered searching for it. I can't remember exactly when it was. Did I save it to my favorites? I think I did. If not, shame on me. Yes. Okay. So, here's me. Right? So there was one night, this is 4th of December 2017 when I was driving Uber. And I was driving a family. This is the mother and this is the daughter, Lily. You're on Twitch now, girls. I was driving a family to a Jack Johnson concert. So if we look up Jack Johnson. Images. Jack Johnson is a singer, and their son didn't want to go, so they had a spare ticket. And they're like, I made friends with them, and they're like, what are you doing tonight? And I'm like, driving Uber. And they're like, do you want to come to Jack Johnson concert? I'm like, sure. So I dropped them off, and then I went and parked the car and joined them at the concert and saw Jack Johnson playing music live for like 2 hours and partied with them. So that was probably one of the best experiences driving Uber. There are a few more, but I'll have to hide those stories, or not hide them, but I'll have to keep those stories for another time. One of the worst experiences is just when you would pick up jackasses and they'd just be absolute dicks and be like, yeah. See, I like to think I'm a pretty friendly guy when I meet new people. I feel like I'm pretty approachable. I feel like I can get to know people fairly quickly. That's kind of a skill that I have. And so this one time, this guy was just being an absolute asshole, like saying, oh, did mummy and daddy buy you this car? And I'm just like, what? Do you have to say those things? And so I'm just like, you know what? I'm just going to not say anything to you and drive you to your place and then move on and go from there. But otherwise, people are generally pretty nice. Driving Uber, I've said that before, I would drive Uber for fun. At the moment, I'm working on too many things, but if I eventually get a Tesla, or when I eventually get a Tesla, I'll start driving Uber for fun. Imagine me picking you up in an Uber. in a Tesla, that'd be a fun time. Okay, now let's start to fine tune. Getting distracted, but that's a great question. Driving Uber was a good time for me. I'm going to delete that. Remember, what's our rule of thumb? ML fit. Early stopping is not defined. I didn't run this cell. I've heard that. Some places, driver typically has that stigma of like a low grade job. But I think any role has its place. You can bring value to others no matter what you do. So unless you're somehow sucking the energy out of other people, chances are you can bring value to society, you can bring value to yourself, you can bring value to others. So I have respect for anyone who brings value to themselves and other people, no matter what it is through. I find it hard to respect people who suck the energy from others for no reason. They're the worst type of people, the ones who suck the curiosity out of life. You don't want to spend much time around those type of people. You know, the people who it's an effort just to be around. You don't want that. You want to spend people with time, like energy is your most valuable resource. So you want to spend time with people who maximize your energy and vice versa. If you can be the type of person who makes other people, their energy levels go up no matter what sort of thing that you do, well then you're probably a pretty good person to be around, and I'd probably want to be around you. If you didn't use mixed precision or use the techniques such as prefetch in the data loading, all right. I suppose your courses, yeah, so my courses are mostly beginner, well, they are all beginner. So ML and data science course is targeted completely at beginners. And this TensorFlow course is targeted at beginners of deep learning and beginners of TensorFlow. But as for an expert level course, I wouldn't even consider myself an expert. But thank you for your comment to say I'm really glad that you can understand my courses. I'm trying to teach in the way that I would like to understand things. Because I know I write the code, right? So I know the problems that people are going to run into. But right now, I can only teach beginner level because I can only teach the skills that I know. And so, what I need to do next is if I want to go to the next level, I have to work on my own projects so that I'm not just teaching things that I haven't actually done myself. So I can teach a beginner TensorFlow course because I've had a fair bit of experience with TensorFlow. Going forward, if I wanted to teach something more advanced, I have to practice that skill myself. In turn, after the TensorFlow course, I've got a project in mind that I'm going to be working on for quite an extensive period of time, as long as it all works out, who knows, that's the fun part about it, to upgrade my own skills as a machine learning engineer. So potentially I could take lessons from that and teach it in a new course, but not until I've done the thing. My moral compass tells me that I cannot teach or give advice on things I don't have first-hand experience with. Thank you, Shavans. I really appreciate it. That's a very kind compliment for you to say. But yeah, that's a kind of long-winded answer. Bahadir, to why there's not an expert level course out at the moment. And also, in terms of like how many people would actually do it, beginner courses have the largest market, as you could imagine, right? Because a lot more people know how or don't know how to code than do know how to code. But then as you slowly get like up and up and up, once you have the foundations of something, like a couple of years experience in programming or whatnot, you start to learn that, hey, I can start to teach myself all of this. So that's where a lot of people get to in their coding journeys. Like because like once you get aside from the basics, like once you get more and more advanced, the things you want to work on become more and more specific. So if you imagine, it's kind of like a funnel. You start up here, you have all these people who are trying to learn just Python programming to begin with. They don't know any code at all. But then as you go down, you could use Python for websites, you could use Python for databases, you could use Python for applications that run on your computer, you could use Python for machine learning, you could use Python for data analysis. And so there's a lot of people just trying to learn base level Python. But then as you start to drill in, there's less and less and less and less people who want to learn the specifics of something. So the more advanced of a skill you try to teach, the less people you have to teach to it. And that's a way from a business perspective, is that if I want to sell courses and use that income to fund future projects, and I'm targeting very, very advanced skill level, of course I need that skill level first before I can teach it, but the market size is not going to be that large if you're doing online. So then it kind of goes to another way of doing things, is you would charge more for an advanced course. So for example, the full stack deep learning course, full stack deep learning, I paid for the sign up of this. This was $750 to do the part where you have chats and whatnot, synchronous online course, right? So I'm enrolled in this. I paid $750. So what's that in Australian dollars? USD. 1,000 Australian dollars, because I believe I can learn some things from these, from the people that are teaching these. Now, is my skill level ready to charge $1,000 for an advanced course? For me personally, probably not, but I probably could. But then again, is that the thing that I want to start working on the most? I'm not really sure. All I know is that after I finish the TensorFlow course, I've got something that's burning inside me that I really want to work on. So stay tuned for that. I'm going to keep this running. I need to piss once again, and I will be back. Ashik asks, when I said about being a fisherman in Vietnam, was I serious about it? Yeah. Well, the point behind that was, and this is a very valuable life lesson, is, or for me anyway, is if you're stuck for an answer to something or you can't make a decision on something, chances are the answer you're looking for lies in the realm of things that you can't yet imagine. So let's just have an example. I need to draw a picture for this because it's probably best understood with a picture. Or app. Okay, so draw. This is what you don't know, and this is what you do know. So of course, what you do know is far smaller than what you don't know. So if you're looking for an answer and you're only looking in here, that's why you might feel lost, right? But chances are the answer, if you're stuck, might be somewhere in this big section. Let's draw another color. Has it got color? Doesn't matter. Might be in this big part of things that you don't know, right? And so the fisherman in Vietnam lesson was basically, in life, you don't have to do anything. So when you feel like you are stuck, you can literally do anything. So if you're like, what should I do in life? What I didn't realize is that if I wanted to, I could go and become a fisherman in Vietnam. No one is stopping me from doing that. Like if I wanted to just change my entire life, go and become a fisherman in Vietnam, I could do that. And so the lesson there was, what I would try to impart on a younger version of myself is just make him aware of the sheer amount of things, the sheer amount of possibilities that there are in life. Basically infinite, right? So when you feel trapped in this small little circle of things that you do know, and you're like, far out, I don't have any of the answers, I feel so stuck. Just remind yourself, hold on, there is a massive plethora of things out there I'm probably not imagining. However, the paradox of this is that it also creates the paradox of choice. So when you have too many options, you lead to no options. So again, life always has these dichotomies, right? On one side, you have an infinite amount of possibilities, and on the other side, you're trapped within your own mental prison because you can't imagine these infinite possibilities. Then if you do imagine these infinite possibilities, you also become trapped because you're constantly thinking about, oh, should I have done that? Should I have done this? Should I have done that? What is the cure? Well, for me, was to try a lot of things, right, in this space of the unknown, to try a lot of things and then see what sticks, and then just become really good at a small section of things. And then everything outside of this, you just got to basically kill. So this is a beautifully drawn diagram of explaining the things that you know, very small, the things that you don't know, very large. If you wanted to become a fisherman in Vietnam, you could. And then once you've tried a whole bunch of things, you've tasted everything, you've opened your eyes to the world that exists out there, there's infinite amount of possibilities, is if you want to cure yourself from the paradox of choice, is to get really good at a subset of a few things. So yeah, that's how I live at the moment. Let's go back to this. Save the model. Now let me know if any of that didn't make sense, because it makes sense in my head, but that doesn't always mean it makes sense in someone else's head. So I can try to explain it from another point of view. if you're going for an internship, Bahadir, and you've already learned a whole bunch, you probably know enough. If you've got an eagerness for knowledge, depends. If you're going for a junior internship, I'll let you in a little secret. Read this article. Let you in a little secret about junior internships. You basically learn like everything you need to know within the first couple of weeks. So it's really about getting your foot in the door. So read that post. How can I gain experience? Yes, Alex, that's a great one. Follow your curiosity. Follow your curiosity. Get out of your mental prison. That is this little bubble. Explore the big bubble. Find which part of the big bubble you like and then create your own little bubble up here. Life in bubble form. We're going to see how many epochs this takes, and then we're going to adhere to our ML Fit rule of push-ups, 5 push-ups for every epoch. And I might have to go relatively soon. How long have we been streaming? Almost 3 hours. This has been a good stream. Have you guys had fun here? I've had fun during this stream. I need to go and start preparing dinner for my family. Okay. Did we beat... And we've also made a fair few good changes to our notebook. Chef Dan is making a roast pork with crackling dish. This is what I'm making. Pork roast with crispy crackling. Look at that. That's what I'm making tonight. Roast pork. Look at all these tips. If you want your pork to cook evenly, stabilize it with alfoil balls. Gravy. Delicious. So I have a butcher down the road. I've got 3 kilos of pork ready to go. I'm going to do all these steps. Actually, not too complicated. I read through it before. And we've got about 7 people over for dinner tonight, so it needs to be a big one. Look at that. Roast pork. I'm very excited for this. So that is dinner. But have you ever been to a recipe website lately? There's just so much crap going on. This person looks like a very nice person, but there is so many ads and crap. I just want the recipe. Look how far you have to scroll down to get the recipe. Look at this. Still not there. Still not there. Still not there. Boom. Look how small that scroll thing is. Look how far we had to just come to get the roast pork with crackling recipe. But that is what I'm making. Pork roast with crispy pork crackling. Very, very excited. Bahadir, if you guys want to see streams, past streams, you can go to the YouTube channel. Oops, Q archive. If you want to see past streams, you can go to the YouTube channel. I'm uploading all of my streams over there. Oh yeah, Sheik, you're right. Following your curiosity doesn't work at all times. There's caveats to the rules, right? Life is not black and white. It's like 100 shades of grey. But as a general heuristic, in the past when I followed my curiosity, things have turned out pretty well. Renuga, welcome back. And hi to Program Nerd, welcome back. And Alex says, you were in cybersecurity and COVID gave me so much free time you decided to learn new skill. ML. Yeah. How good is that? COVID kind of, okay, it did fuck up a lot of things, but it also gave a lot of people a chance to kind of reevaluate what they were doing, because the whole world went on like a pause, basically. It's like, pause, we've got to deal with this massive problem. Now here's some free time to think about whatever the fuck you're doing. Is it the right thing that you should be doing? Think about that. So we got one more epoch to run through, and then after that, I'm probably going to bounce. So I'm going to write up to here. Okay, we did well. We got up to the part where we can just reload a model from Google Storage. Up to here. So we've got a few minutes left on this epoch. Yeah, you're right. This roast tonight is going to make me cook. It's going to take me about 3 hours to cook, and we're going to devour it in about, less than 20 minutes. You're right. Hey, Renuga started learning programming while you were in quarantine of April 2020. We were all learning programming during quarantine. So much fun. Okay. ETA, 255. Then Chic. That's so cool. You love the COVID times. Yeah, I think I don't know. Who knows what's going on with the virus? I mean, we're like a year into this stuff, and I don't think anyone really knows what's going on. It's kind of just, it's like machine learning, right? It's just, you just run experiments every so often. How far are we through? Oh, wow, we got up to the last one. Yes. So we are nearly finished this entire notebook. I'm going to tomorrow probably make some graphics for it. And some slides. And then I can record the videos. Hot diggity damn. Look how much we've been doing in the streams. This could be another experiment for later. Yeah, see, that's the power of online learning. What Renuga is saying is, I remember school, right? There were the things I'd like to learn at school, and then there were things I didn't like to learn. And I always found it like confusing. Why can't I just spend all of my time learning the things I want to learn? And that's kind of what I do now, is I'm interested in ML, and so I spend all of my time, or basically all of my time, on ML. Whereas school kind of like, you do an hour of this, you do an hour of that, you do an hour of this, you do an hour of that. And if you're like, I really like this 1 hour of math that we do. Nope, you have to do another 1 hour of geography or something like that. Bahadir, my next stream will be probably tomorrow. Around the same time. I'm going to Twitch are telling me I need to stream 7 days. So look at this. Stream. I've streamed for over 8 hours, but it says I need to stream for 7 days. So can you see that? So if I want to get affiliate, which I do, because why not? Stream for 8 hours, I've done that. Stream on 7 different days, I haven't done that. An average of 3 viewers. So thank you very much if you're watching this. I need to do all that within the 30-day period. So thank you very much if you're following me. And thank you very much if you've been hanging around and viewing, because I need to fulfill these criteria to get to affiliate. I don't even know what that means, but it's got some pretty colors here and I've been sucked in. But I actually do just like streaming because it helps me to think out loud and whatnot. Yes, we beat the deep food paper. Boom. TK, we beat the deep food paper. Okay, so I'm going to save this. Save a copy into GitHub. Write text annotations for a bunch of sections. About 1 or 2 to go. TK. TK means TK equals come back and check later. Okay, did that update? So yeah, TK is like a note for you to come back and check it later, or a note for me. So I use that with all my writing. So if I'm writing something and I want to come back and check it, then I can just search for TK. So if I come back to this notebook, right, and there are things I want to come back and check, I write TK, and then I see that there's 27 TKs to come back and check. So I make sure that all of these sections are fixed. And why TK? Well, TK, the letters TK don't really appear next to each other in that order. So that's why I write it as TK. It's sort of like to do. But I mostly use TK. All right. So, Ashik, you're looking to move to Norway? Wow, that'd be amazing. But we're going to end the stream. Thank you so much to everyone who joined in. Bahadir, Ranuga, Ashik, Alex. I really appreciate it. You guys sticking around. Thank you for offering the commentary and talking. Programmer Nerd, thank you for the follow as well. I will see you all next time. Don't forget, you can watch all of the past streams in the archive YouTube channel. I'll upload them there so you can watch it later. But otherwise, thank you for joining in, and I'll see you next time. Keep machine learning, keep moving, and keep... Oh, you know what? We didn't finish. We need to finish off. We didn't finish off with our ML fit rule. We trained for 5 epochs, so we need to finish off with 25 push-ups. Okay? 25 push-ups and the stream is done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Woohoo! All right, so we adhered to our ML fit rule. ML fit, 1 epoch equals 5 push-ups. If you can't do push-ups, you can do squats, but that is it for me. See you all in the next stream. Thank you so much for tuning in.